Okay, we're going to do some geometry and get to the idea of similarity and how you can get started with some of these questions. If you've got similar triangles, you can make the proportions. You can try and get some marks. Well, here's this first question here. They give you all this stuff. They've got a cyclic quadrilateral ABCD in this circle. They give you two right-angled triangles. They give you a triangle ABC with a right angle there, and another triangle AMD with a right angle there. Okay, and then they say, prove that MC is a tangent to here. Well, if it's a tangent, the tan chord theorem, so we must have to use the converse of the tan chord theorem, and we must be having to prove that this equals x. Hey, there's about 4 or 5 different ways you can do it, but this is one way. This is the way I did it. I looked at it, and I went, hey, this is 90. That's x. It's a right-angled triangle. It's got to add up to 180. The only way is for these x's to disappear. So minus x plus x is 0. 90 plus 90 is 180. So that angle up there, A2, must be 90 minus x. And this angle A1 must be 90 minus x because it opens up to an equal chord length. Equal chord length, angles on equal chord lengths. So that must be the same angle, 90 minus x. Now, in triangle AMC, if that's 90 minus x and that's 90, by angles in a triangle, that must be x. Well, then we've done it. We've shown that MC is a tangent because the converse of the tan chord theorem. The angle between the tangent and the chord equals the angle up at the top of the triangle here, and there we would have proven that one. But now they want us to figure out, now they want us to figure out, there we go, they want us to figure out, they want us to find some similar triangles, and they want us to prove that triangle ACB, that triangle right there, is equal to triangle CMD. So I like to use a little color, CMD. I can look at the triangles that we're talking about here. And all we have to do is match up two angles. Well, that 90 degrees pops up right away. That angle ACB, where the C is, and DMC, where that M is, are both 90 degrees. Well, there's a mark. Now, I see that D2 must be equal to x. You see that angle x up there? There's a cyclic quad, ABCD, and that's the exterior angle of the cyclic quad. So D2 must be x, and angle B must be x. Okay, so therefore, they must be similar triangles because we've matched up their 3 angles. If the angles are the same, then they're called similar triangles. Now, this is a pretty tricky question here. They ask us to prove this really tough-looking ratio with squares and all this stuff. Well, I don't know what's going on here, but they seem to want stuff with DC. They want stuff with CM. So all you do is make the ratios. Make the ratios. Match them up. If they're similar, what one does MD go with? Well, MD goes with BC. Right there, MD goes with BC. And which one goes with CM? Well, that's the first 2 letters. CM over AC go together. And the ratios will be the same. And the last one is DC out here. DC goes with AB. Right there, AB. And there, those are your basic ratios. And it's similar triangles that make it true. So you might get a mark just for getting those ratios. Now, we're trying to get to DC squared, and they often do this in these tough questions. Because BC equals DC, I can rub out this BC here and put a DC. And put these together with this DC over AB, and look, DC times DC is DC squared. Well, that's your first part of doing this. But look, I got some marks just by making those fractions in the triangle, matching up the letters and making the ratios, and writing similar triangles. There was this trick here of seeing that these two are the same and rubbing out the BC and putting DC, but they do it again. they do it again with two new triangles, but they do exactly the same thing and make ratios. They go for another triangle, this big triangle AMC, and try and prove that it's similar to CMD, to the little one here. And they do it, they prove it, they make the ratios, and then they finish the whole thing off. It's pretty tricky, but you don't have to get nothing in it because you can make these ratios. You can get started. Okay, and that's it.